So statistics, it's the study of variation, but then we really need to unpack what is variation? And in statistics, we often are not just talking about any old kind of variation, we're really talking about variation in data. And so let's take this outcome variable that we've measured out in the real world, and we could see there's variation here. Let's say we've measured people on some outcome variable, right? And we can see, oh, not all people are the same. They vary, you know? And so even though a lot of people have like around 61 or 62 as their score on this outcome variable, there's a bit of variation here. There's some people who are scoring all the way up to 70, some people scoring all the way down to 50, and so there's variation. Now, if we had taken another measurement, we might see a very different pattern of variation. For example, here we see a lot more variation in this distribution. They seem to have roughly similar centers, like for instance, it seems to be around 64, low 60s perhaps, but there's a lot more variation in this particular distribution. We see people scoring all the way up to 80 and all the way down to 40. Now, what do statisticians do with this variation that we see in distributions? Often we create a model, but that begs the question, what is a model? And so in this case, we're just going to draw from our regular old understanding of models. For instance, if we have a White House, the real White House, we might create a scale model of it to help us understand some things about it. Like for instance, this scale model, it's not the same as the White House, it's not even the same color, but from it we could represent certain parts of this White House. Like for instance, it has 4 columns and the real White House also has 4 columns. Now, what do we do with a statistical model? It's not just a small version of the distribution. In fact, it's just going to be simplified somehow, and often it's simplified by having fewer things about that distribution. For example, a simple model is the mean as the model of this whole distribution. It's simpler because it's just one number. This distribution is a whole bunch of numbers, but the mean is just one simple number. In this case, the mean seems like around 64. And you could see that 64 is not a perfect representation of this distribution. This distribution is a lot more varied. There's a lot more details to it. It totally misses this idea that some people scored 80 on this outcome variable, but it's a good representation because it roughly captures something about this distribution that's important, namely the center of it. Now, one of the things we could do with a simple statistical model is we could use it to predict the next data point that we might gather from the world. Let's say I told you, oh, we're going to go out there and measure one more person on this outcome variable. And given that you have no other information about this person, you might think, well, maybe they're also going to be about 64 on this outcome variable. It won't be perfect. You'll be off by some amount, but this might be one of the better guesses that you could make given this information. Now, there are going to be situations where that simple model is a better model and some cases where it's a worse model. Take, for instance, this top distribution. We could see, oh, because there's less variation around the model, that this model is quite a bit better. But in this bottom distribution, there's more variation around the model. And because of that, it's not going to be quite as good of a prediction, not going to be quite as good of a representative of this whole distribution. Now, one of the things we're doing here is we're making a subtle shift. Instead of just looking at how much variation there is, we're looking at how much error there is from the model. If you predict that the next person is going to be 64, in the case of this top distribution here, you might not be off by that much. Your error will be smaller. But if you guess, oh, this next person is going to be 64 and the bottom distribution is a good representation of the world, then you will be off by more on average. So let's break down this idea of error from the model a little bit more concretely with this one data point that we've colored white. So here we see this distribution, there's variation, and here's this simple model, the mean, 64. But you could see there's this data point is not exactly our model. Our model is wrong, right? Well, how wrong is it? We could represent how wrong it is by this distance between the data point and the model. So you could think of all data points as being made up of two components. You could think of each data point as being part of it is our model prediction, and part of it is how off that model is from the actual data point. Now, that works well if the world is a simple place that could be described with just one number. But let's say we know a little bit more about the world and its complexity. Can we make our simple model a little more complex? Let's say we know that this distribution of people actually is made up of two different groups of people, the red group and the yellow group. Now, the red group, you could see, oh, they vary too. Just because you're in the red group doesn't mean that you're all the same. And just because you're in the yellow group doesn't mean you're all the same either. How can we make use of this little bit more information that we have? Well, one of the things you could see is that the red group, although it's not exactly perfect, it's almost like they tend to have lower scores on this outcome variable than the yellow group. And that's not true for every single person, but it's kind of true as a whole, right? So if we put up the means for the red and yellow group, you could see that the red group's mean is smaller or lower than the yellow group's mean. Now, one of the ways that we might use that information in our two-group model is by saying, oh, if I knew what group you came from, then I can make a different prediction about you. So if I knew that the next person we're going to measure comes from the red group, we might say, oh, I predict that their score is going to be a little bit smaller. Maybe their score is going to be around 61. But if I knew that this person was going to come from the yellow group, I might make a different prediction. I might say, oh, I think this person's score is going to be closer to 70. And so this model is very similar to the simple model of the mean that we saw before. Now we're just using two means to represent the means of two different groups. And because of that, we're going to call this the two-group model. It's slightly more complex than the one-group model.